So if we were talking about, we're going to talk about doing calculations with significant figures, and if we were talking about those measurements to the moon that we were talking about yesterday, we'd be talking about one way that we measured it at 300,000 miles, so 3 times 10 to the fifth, and the other way we measured it at 250,000 miles, 2.5 times 10 to the fifth. So each one of these was like an estimation, right? We rounded off. In one place, we rounded off to one digit, and in another way, we rounded off to two digits. So if we ran calculations using the distance to the moon, right? One calculation would be less precise than the other, because this calculation was rounded off to the 100,000th place. This calculation, 100,000 place. This calculation was rounded off to the 10,000 place. So this calculation was way less precise. There is a way greater range where that measurement might fall here. It's way vaguer. This measurement is much more vague than this measurement. Are we agreed? And so therefore, this calculation, the same calculation could be run with these two numbers, but this one would be far less likely to be correct because this number is far less likely to be correct, simply because it is rounded off to the 100,000 place, and this one is rounded off to the 10,000 place. This one is more precise. Are we agreed? So there has to be a way for us to, a rule for us to use that says that when we come up with an answer, we round off to a specific place, showing that our answer is accommodating for how precise our measurements are. In other words, I want to make sure that if I run a calculation with the measurement to the moon here, that my answer shows that this measurement of the moon was this imprecise. And I want to show that if I run a calculation using this measurement to the moon, that my measurement, the same calculation, that the measurement of the moon in this calculation was this imprecise. So that in the end, when I compare the two answers, it shows that this one was more precise than this one, because the rounding off is different, right? They should be different, these two answers, because this one is way less precise than this one. So how do we do that? We have a set of rules that tells us that when we run a calculation, we go back to those original measurements and we round off our answer according to the original measurements. So this one would get rounded off differently than this one. All right? So that's what we're going to talk about today, is the rounding off of your calculations by going back to your original measurements. And in fact, they're doing this in physics right now. So this is not like why do we have to do this? Because this is science, and today is the day you're learning this for the rest of your scientific life. Okay? This is a skill that is the rest of science, forever. This is it, forever. Okay? Because for the rest of your scientific life, every calculation you do is as precise as the original measurements. Okay? All right, here we go. So we have multiplication, division, and addition and subtraction. Two different rules. The first one, multiplication, division, the answer to the problem cannot have more digits than the measurement with the fewest digits. Oh, well, that makes sense, because here, this one has one digit, one significant digit, and this one has two. So your answer can't have more than one digit. Your answer can't have more than two digits. Bam! This one is now more precise than this one. There you go. That's how it works, all right? So we say overall, for multiplication and division, the answer cannot have more digits in it, more significant figures in it, than the fewest digits overall, okay? With addition and subtraction, your answer cannot have more digits after the decimal than the measurement with the least number of digits after the decimal. So here we write after the decimal. Both of them have to do with the least number, but multiplication and division is overall, and addition and subtraction is just after the decimal. So I'm going to repeat that. They both have to do with the least number of digits, but multiplication and division has to do with the least number of digits overall, and addition and subtraction has to do with the least number of digits after the decimal. Okay? So let's take a look. So first, we're going to do the multiplication one. So plug it into your calculator with me. 6.2 E2 times 8.33 E5. The answer I get is 5.1646 times 10 to the 8th. Now I look. Here I have 2 digits overall. Here I have 3 digits overall. My answer cannot have more than 2 digits. That is the least number of digits overall. So I go over here, I draw my line. 6 carries 1 over, so my answer is 5.2 times 10 to the 8th. 2 digits overall. Questions? Okay? All right. Because you see, the 8.33 was more precise. I can only have my answer be as precise as the 6.2. Let's do the addition one. 7.3321 plus 9.90 equals. So my answer here, 17.2321. But here I have 4 after the decimal. Here I have 2 after the decimal. I can only have the least number of digits after the decimal. That's 2. So I'm going to round off here. Oh, something happened. What happened? I didn't add right? I did not add right. 7.3221. Right, so this is 2, 7, 2, 2. My mistake. Okay, everybody okay? Sorry, I had the wrong number. All right, so now I draw my line here. 2, 2, 1. Excuse me, all right? So my answer is 17.22. Okay, are there any questions? How did you? Why did you? Where did that come from? I don't understand the rules. How did you count? Yes. I used my E button here, 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 here. 5.2 times 10 to the 8th? Did I multiply that times what? I'm just saying, did you do that to get the 5.1? Yeah, I multiplied 6.2 E2, like we were doing yesterday. 6.2 E2 times 8.33 E5. Right, if you're not getting the same answers I'm getting, that's definitely cause to raise your hand. So If you're not getting the same answer, yeah, that's like, I did not get the same answer you got. Yeah.
So for the addition and the subtraction, are you never gonna have the x to the, like?
Oh, great question. Excellent, because I forgot to tell you that. So, addition and subtraction. So let's keep, no, not let's. We are going to keep addition and subtraction in flow. Here's why. Now we're writing, okay? If the equation has both addition and subtraction and multiplication and division, use the multiplication and division rules. Now, almost all of our addition and subtraction, almost all of our problems in this class will have addition and subtraction and multiplication and division. And therefore, we will almost always only be using multiplication and division rules. It is only in this unit, pretty much, that we will be using addition and subtraction rules. So for this unit, we will be only using addition and subtraction rules, and so therefore, to avoid any confusion, you will leave addition and subtraction problems in flow. Because in this case, if we were to put this, if some of us were to choose to put this in addition, this into scientific notation, that would change the answer to 1.72, wouldn't it? Times 10 to the 1. So now our answer would be different, wouldn't it? Does that make sense? Right? Some of us would have 1.72, because 2 digits after the decimal, and some of us would have 17.22, 2 digits after the decimal. So let's not muddy the waters here. Let's just leave the water as it is. And so for this unit, we're just going to leave all, because we're isolating multiplication, division, and addition, subtraction. And since we're doing that, let's just leave all those addition, subtractions in flow. Then we're all going to get the same answers. So if the addition, subtractions are in flow, just leave them there. If they're inside, leave them there. All right, just leave them in whatever they're in. And then we're all going to get the same answers. Multiplication, division, we're following our scientific notation, our actual scientific notation rules. And the reason is because we're going to end up with exponents here. So let's use them, all right? But flow, it's just this unit. And then we're done. Flow. Addition and subtraction, it's just this unit, and then we're done. All right, then we're always going to be using multiplication, division. I mean, I really honestly can barely think of any time that you're going to use addition, subtraction after this, okay? Excellent question, Carson. Thanks for reminding me. The next thing is you're going to only Sig Fig, it's now a verb. Sig Fig is now a verb. It is a noun when it's a Sig Fig, and it's a verb when we're going to Sig Fig, okay? Once. You only Sig Fig once at the end of the problem. So we have very long problems. They make you feel very smart, and then at the end, you Sig Fig one time. So we finish the whole problem, and then you go back up to the original problem, you look at your original measurements, and they tell you what your Sig Figs are going to look like. So you only Sig Fig one time. Ian. I am not boring. I may be scatterbrained and disorganized, but boring? Nah. All right. Next. Let's try these. Ready? So you're going to do the first problem on your calculator. I mean, geez. Okay, first problem on your calculator. Here we go. And then let's compare our answers. So on your calculator, you should get this. Now, how many digits do we get? You can show me with your fingers if you'd like to. How many digits? How many digits can I round to? That's what I want to know. How many digits can I round to? Okay, so I see 4, I see 1. 1, more ones. Okay, the answer is 3. So here, multiplication, the overall number. Okay, so I have 4 here, 1, 2, 3, 4 non-zeros, and I have 3 here, 3 non-zeros. So the lowest number that I have here is 3. So I'm going to draw my line. It's a 4, so I'm going to cross these out. So my answer is 6.78 times 10 to the 1, or 67.8. Would that be acceptable on a test? 67.8, would I be allowed to do that? I would. It's lower than 99, so that would be okay. Miss Paxton would be, that's fine, 67.8. That's good. We can do that, okay? All right, let's try the next one, a division problem. If you're not getting the right answer, that's a problem. If you're not getting the same answer on your calculator that I am, that's a problem. Where's your name tape? Your name tag?
I think I broke my calculator.
Charles, is that it? Charles? You think you broke it?
It just keeps giving me syntax error anytime I put anything in.
Oh, no, you didn't break it. It broke you. No, Charles, you didn't break it, I swear. You're just not telling it what it wants to know. I'm pretty sure.
9 times 9 is 86.
We'll see that today. Oh, man. They know how much I care. All right. So, 5 divided by 8.26 equals. Okay, so this is what I get. I get 8.80487. Then we don't care, times 10 to the minus 2. So how many digits do I get? So I see 3 here and 2 here. Lowest number, 2. So I see 2, so I'm going to draw my line. This is a 0. So I get 8.8 times 10 to the minus 2, or 0.088. Is that acceptable on a test? 0.088? No. Nothing with zeros in front of it. Nothing with zeros in front of it. This is not acceptable. Okay? No. Anything between 1 and 99 is okay. But if it has a 0 in front of it, it must be in scientific notation, okay? Yes. Lily, right? Sorry, I just swore. Sorry. I'm trying so hard. Okay.
How do you know, like, how many decimals to cross out, or, like, where to start when you cross out the decimals? Like, the 8.8048 says
How do I know where to round off?
Yeah.
So, good. So here, okay, let's back up a little bit. So the question is, where do I round off to? Right, that's exactly what we're doing here. So the question is, how many digits do I get? So that I get the number of digits that I get I look at the overall, because it's a multiplication problem, a division problem, the overall count of numbers in each problem. So here I had 3, here I had 2, and I'm going to take the lowest number of digits, which is 2. So that's how many digits I get. So I get 8.8. That's all I get. Then I draw my line and I round off to 2 digits. So I get 2 digits. Okay? All right. Other questions? Great question, Samaya. All right, moving on. Next one. Ready? All right, so Samaya. Okay, Samaya. Right. 2.4567. Okay, so the answer I have here is 1.1567. How many digits do I get? How do I know where to round off? To tenths. Okay, so Carson is correct. The second number is a subtraction, so the second number tells me I only get 1 after the decimal, because subtraction tells me after the decimal, the lowest number of digits after the decimal. That's 1. So I'm going to round off here. 1.2. That's my answer, 1.2. Do number 4, please. Where am I rounding off to? How many digits do I get? Raise your hand if you can tell me. Z? I get 4 digits. How do you know, Z?
Because the first number, you only get 1 digit after the decimal.
I only get 1 after the decimal here because it's addition. I get 3 after the decimal here. So that means I get 1 after the decimal here. So I'm going to draw my line here. I'm going to roll this over. So I get 4 digits. 103.1. This is an addition. It is the number after the decimal, the lowest number after the decimal. Addition and subtraction, it's the lowest number after the decimal. Multiplication and division, it's the lowest number overall. Multiplication and division, the lowest number overall. Addition and subtraction, the lowest number after the decimal. Are there questions? Are we ready to do some practice on the boards? Great. Let's talk about the board. So we go to 49. Yes, yes, yes. Okay, good. So we're going to go to the boards. You're going to get a marker. You're going to get a rag. There is room in this room. There are 29 of you. There's room on these boards for 35 kids. I got a grant from GoFundMe to get these boards. I've been doing this for 15 years. This is how I teach. We're going to be at the boards often. All right. So you go to the boards. The first thing you do is you say, hi, I'm, and you introduce yourself to the kids that don't know your names or that you don't know their names. If you don't remember their names, just introduce yourself and say, hi, I'm so-and-so, I don't remember your name. Okay, we're all in agreement that not remembering names is okay, right? Let's just get that on the table. Now, being at the boards, you're going to have tall kids up here because there could be 6 people at this board, all right? So you're going to have tall kids up here and tiny people down here, right? So you're going to be over each other. Please don't like being armpit underneath. Be sensitive to that. So if there's too many people at a board, go to another board. I can get like 10 people, 12 people at those boards. All right? So there's plenty of room, trust me. Okay, now, being at the boards does not mean you copy from each other. When you're at the boards, I can see everybody's work. So that means that I can look over and I can say, Colston, I'm seeing that your molar mass is wrong. Can you check that? I don't have to go over and go, So now I can see everybody's work, but more than that, I can say, Ava, can you help Josie? Or Josie, can you help Ava? So now Ava's my tutor. I don't have to work with Ava, or Josie's my tutor. I don't have to work with either of them. Or I can say, oh, everybody stop. Ember's doing something really well up at the front board. Ember, can you explain what process you took to do that? Now Ember's tutoring the whole class. Right? So everybody becomes a teacher, everybody's helping everybody, and I can move forward and help other kids, okay? So this is how we all work together, all right? You're gonna find that being at the boards is the best way to learn. Now, I move quickly, we don't pause between problems, so you need to be on the ball. I'm gonna call out the problems, you're gonna write the problem, and then you're going to solve the problem. And then I'm gonna walk over and I'm gonna say, today, Alina is the example. And then Alina's gonna step beside and everybody's gonna back up against the counters so that people down there can see Alina's problem, okay? And I'm gonna run through the problem. Alina might have a common problem in her problem that I'm seeing around, so I might say, oh, Alina didn't do the units right, or it might be that Alina's done everything really well, or Alina might have taken hers one step further, and so I'm showing a different process. So when I choose you, it's not always about the fact that you're right, although often you are, but maybe you're not. Maybe you've done something that everybody's done something wrong, okay? So we're always learning. Being wrong in my class usually means that you're showing a learning opportunity. Being wrong in my class is absolutely fine. Are we clear? Okay, get a marker and a rag and find a space on the board. Move quickly, please, because we are running out of time. We only have about 6 or 7 minutes, which is about 3 problems, okay? Rag, markers. Oh, I'm going to turn off my projector so you can move right up into that spot if you guys want to. All right. Feel free. Move right over up behind my desk. Yep. Okay, let's go. I got your first problem coming up. Find a place. Let's go. It doesn't matter where you are. Here we go. First problem. 1.40082. 1.40082. Right there, Chuck. Straight ahead. Plenty of markers right here. How many digits are there? Just throw it away. It's a dead marker. How many digits are there? Then put the 6 up there. All right? Then you put 6 up there. Put your answer right up there. All right? Okay. Good. Yeah. All right. Okay, Gabriel, how many digits are there? 6. There are 6 digits in that. Okay, good. First problem. Ready? Here we go. 3.0 centimeters times 4.00 centimeters. Yep, repeat. I always say repeat before I repeat it. Repeat 3.0 centimeters times 4.00 centimeters. You're going to solve it, and you're going to put your answer on the board. Help each other if you need to. Make sure that you include units in your answer, please. Use your calculator if you need to. 3.0 times 4.00 centimeters times 4.00 centimeters. Don't forget your units. which is great. So if you guys could flatten back so that they can see, right? Okay, great. So 1.2 times 10 to the 1, which is great. That is perfectly acceptable. Notice she has 2 digits, which is excellent, due to the 3.0. So is the number 12 acceptable? Yes, it is. 12 would be acceptable also. She has centimeters, okay, as her unit. So I would like to see centimeters squared, because centimeter times centimeter, like x times x, so x squared, this would be centimeter squared, okay? So the answer would be 1.2 times 10 to the 1 centimeter squared, okay? All right, you guys, so I'll struggle a little bit tonight on the homework. I'll put up a couple examples on Canvas for you to look at, all right? So when you go to Canvas tonight, you'll see a couple more examples, okay? I've got your name tags, don't worry about it. Just drop everything in the bin. And I've got your name tags, and we'll see you tomorrow.